Hello dear viewers. I am excited to have you back for another informative video in AutoCare ZTA YouTube channel. Today, I am discussing a common yet critical issue that can affect any vehicle owner: overheating. Whether you drive a sedan, SUV, or truck, understanding the causes and prevention of overheating is crucial for maintaining your car's health and avoiding costly repairs. So, let's get under the hood and explore what causes your car to overheat, how to identify the signs, and most importantly, how to prevent it from happening. Stay tuned. Why does a car overheat? A car's engine generates immense heat during operation. To prevent this heat from causing damage, a cooling system circulates coolant through the engine to dissipate the excess warmth. However, various factors can disrupt this system, leading to an overheating engine. Common culprits include coolant leaks, a malfunctioning water pump, a clogged or damaged radiator, a faulty thermostat, low engine oil levels, a broken radiator fan, or a blocked heater core. Essentially, any component involved in the cooling process can potentially fail, causing the engine temperature to soar. Overheating can have severe consequences, including engine damage, so it's crucial to address the underlying issue promptly. Regular maintenance, such as checking coolant levels, inspecting hoses and belts, and ensuring the radiator fan functions correctly, can help prevent this problem. Overheating symptoms typically include the engine temperature gauge climbing above the normal range, the overheating warning light illuminating, steam or smoke emanating from the engine compartment, reduced engine performance, and unusual engine noises. If you encounter these signs, swiftly pull over to a safe location and turn off the engine to allow it to cool down. Common causes of car overheating include: Number 1. Cooling system leaks. Coolant leaks can deplete the coolant level, reducing the cooling system's efficiency. Coolant leaks. A car's cooling system relies on a specific amount of coolant to efficiently transfer heat from the engine to the radiator. When a leak develops, coolant gradually escapes the system, causing a decline in its fluid level. With less coolant circulating, the engine's ability to dissipate heat is compromised. As the engine continues to operate, it generates heat at a constant rate. However, with a diminished cooling capacity, the engine temperature begins to climb. This escalating temperature can lead to a host of problems, including reduced engine performance. Number 2. Faulty water pump. This component circulates coolant through the engine. A malfunctioning water pump can hinder coolant flow. The water pump, the heart of the cooling system. A car's water pump is a crucial component in the cooling system. Its primary function is to circulate coolant throughout the engine. This coolant absorbs heat generated by the engine's combustion process. The water pump propels the coolant through a network of passages within the engine block and cylinder head, allowing it to absorb heat effectively. From there, the heated coolant is transported to the radiator where it's cooled before being recirculated. This continuous flow of coolant is essential for maintaining optimal engine temperature. Consequences of a faulty water pump. When a water pump malfunctions, it can significantly disrupt the cooling system's efficiency. If the pump fails entirely, coolant circulation ceases, causing the engine to overheat rapidly. Even a partially compromised water pump can reduce coolant flow, leading to less effective heat dissipation. Over time, insufficient cooling can result in severe engine damage, including warped cylinder heads, blown head gaskets, and piston damage. Recognizing the signs of a failing water pump and addressing the issue promptly is crucial to prevent costly repairs. Number 3. Radiator issues. The radiator is a vital component in a car's cooling system, acting as a heat exchanger. Its primary function is to transfer heat absorbed by the coolant from the engine to the surrounding air. This heat transfer process is essential for maintaining optimal engine temperature. However, various factors can compromise the radiator's ability to dissipate heat effectively. Clogging, often caused by debris or rust buildup within the radiator fins, can significantly hinder airflow. This reduced airflow diminishes the radiator's capacity to cool the coolant, leading to engine overheating. Additionally, physical damage to the radiator, such as leaks or bent fins, can also disrupt heat dissipation. If coolant leaks from the radiator, the system loses its ability to absorb and transport heat, causing the engine temperature to rise. A clogged or damaged radiator can prevent efficient heat dissipation. Number 4. Thermostat problems. A thermostat is a critical component in a car's cooling system that regulates the flow of coolant. Its primary function is to control the temperature of the engine by opening and closing a valve to allow coolant to circulate through the radiator. When the engine is cold, the thermostat remains closed, directing coolant to circulate within the engine block until it reaches optimal operating temperature. Once the desired temperature is achieved, the thermostat opens, allowing coolant to flow through the radiator to be cooled before returning to the engine. Consequences of a malfunctioning thermostat. If a thermostat fails in the closed position, it prevents coolant from reaching the radiator. This can cause the engine to overheat rapidly, leading to severe damage. Conversely, if the thermostat remains stuck open, the engine may struggle to reach optimal operating temperature, affecting performance and fuel efficiency. Additionally, a faulty thermostat can cause inconsistent temperature fluctuations, leading to erratic engine behavior. Therefore, it's essential to address any issues with the thermostat promptly to prevent costly engine repairs. A stuck thermostat can prevent coolant from circulating properly. Number 5. Low engine oil level. Oil helps to cool the engine. Insufficient oil can contribute to overheating. Oil's cooling role. Engine oil serves multiple critical functions, including lubrication, reducing wear, and cleaning engine components. When the engine oil level is low, the oil's capacity to absorb heat is reduced. This means the engine components are exposed to higher temperatures, increasing the risk of overheating. Insufficient oil can lead to increased friction between engine parts, generating even more heat. Number 6. Faulty radiator fan. The fan helps cool the radiator. If it's not working correctly, the engine can overheat. The radiator fan plays a vital role in maintaining optimal engine temperature. It's specifically designed to draw cool air through the radiator, accelerating the heat dissipation process. When the engine is running at low speeds or idling, the radiator fan becomes especially important as there's less airflow from the vehicle's movement to cool the radiator. Overheating risks with a faulty fan. A malfunctioning radiator fan can significantly impact the cooling system's efficiency. If the fan fails entirely, the radiator's ability to cool the hot coolant is severely compromised. This can lead to a rapid increase in engine temperature, potentially causing severe damage to internal components. Even if the fan is operating at reduced speed or intermittently, it may not be able to adequately cool the engine under demanding conditions, such as heavy traffic or hot weather. Regular inspection and maintenance of the radiator fan are crucial to prevent overheating and ensure optimal engine performance. Thanks for watching. If you enjoyed the video, please hit the like button and subscribe for more great content.